Now we want to demonstrate the quality and the stability of the high voltage provided by the SHR. For this, we use here a little device. Basically consists of an high voltage capacitor that allows to decouple the AC component from the DC component of the high voltage, so that we can display the AC component directly here on an oscilloscope. This is basically the parameter that we specify as ripple and noise, so the noise on top of the high voltage. You can see here directly. So also connected to this ripple test adapter is a switchable high voltage load where I can simulate different load conditions to see how the ripple changes or stays the same. So, okay, I connect this to a high voltage channel, channel number 0. And now select this channel, set up a voltage. We directly go to the maximum voltage of 6 kilovolt, apply it, switch it on. So we are ramping up. So now we arrived. And we can have a look at the oscilloscope. So what we see here, we have to wait a little bit for everything to stabilize. What we see here is the ripple and noise, or the AC component on top of the DC high voltage. So if we have a closer look here, this is now set to the maximum resolution for voltage. So basically one vertical division is 1 millivolt. And the horizontal division is 10 milliseconds per division, so that means the whole range from the left side to the right side corresponds to 100 milliseconds, which would be a ripple and noise value for 10 hertz and higher frequencies. So here we have a number for the peak-to-peak measurement value of the curve we see here. So this is somewhere just a little bit above 1 millivolt, the ripple we have here at 6,000 volts currently, with the high voltage load switched off, so in no load condition. We can now also give some load. Just switch it on and wait a moment to stabilize. So again, we see that the values peak to peak for ripple and noise didn't change much. It's just above 1 millivolt. So right now we can have a look here at the current we actually see at this load conditions here. This is 1.2 milliamps. I can increase it a little bit that we get closer to the maximum value of 2 milliamps. Let's say switch it here. This was a little bit too much. Okay, this is almost the maximum load we can have. And again, the ripple and noise is still quite small, so below 2 millivolt peak. We can also go to a different operation point. Let's say we reduce the voltage, go to 1000 volt, for example. So ramping down. And again. Have a look at this oscilloscope. And the same picture, we have a ripple noise value just around 1 millivolt. This is now at a relatively low load. Since we reduced the voltage, I can increase the load a little bit. So going again back to something like 2 milliamp. Okay. And even here we see a very stable high voltage.